Okay, everybody, what is going on? We've got another video, and this is implicit differentiation. So we're going to find the derivative of implicit functions. So you may have a function that's in terms of x and y, and sometimes you may have a function in terms of x and y that you can't solve for y. So how do we find the derivative of that? Well, we use implicit differentiation. So let's go ahead and get started. We've got several examples. We've got some word problems at the end. So let's get into it. So to differentiate implicit functions, so to find dy dx, when y is defined as an implicit function of x, we differentiate each term of the equation with respect to x, okay, regarding y as a differentiable function of x. We then solve for dy dx, which once you do that, your answer is going to usually be in terms of x and y. So let's just kind of let's look at it for a second, like an implicit function. Here we have one. Okay, they want us to find dy dx. All right, so we've got y squared plus 2x squared equals 5, and we want to find the derivative of y with respect to x. Now, I'm going to explain to you what's going on, and then I'm going to tell you an easy way to do it. Okay, but I think it's important you understand what's going on also. All right, so let's look at this first example. So we've got y squared plus 2x squared equals 5. Take the derivative just like you always do. Okay, using the power rule, product rule, quotient rule, chain rule, all of that stuff. Everything's normal. So we've got the derivative of y squared. So that's going to be 2y, all right, and then times dy dx. Okay, so that's the derivative of y squared. So what's going on there? Well, remember when you had something like this, say x squared plus 3 squared, and you took the derivative of that. Remember, you would bring the 2 down, x squared plus 3, subtract 1 from the exponent, so that's raised to the first power. But then you would do times the derivative of what's in these parentheses. So that would be times 2x. This right here is the derivative of what's inside these parentheses here. So a way that you can look at this is you can look at this, instead of having something like this in terms of x in the parentheses, what if we had y in the parentheses? Well, you're doing 2 times y, subtract 1 from the exponent, so that's to the first power, but then it's times the derivative of what's in these parentheses here, which is what's the derivative of y, dy dx. And that's where it's coming from. It's like you're using that chain rule. So the easy way to remember it is take the derivative just like you always do, okay? Using all those properties you've learned. Take the derivative just like normal. But whenever you take the derivative of the y term, you tack on a dy dx. That's all it is, okay? And I tell you what I'm going to do here. I'm going to erase this. I want to 2y dy dx. I want to do it in a different color. All right. So that's see, we take the derivative of y squared. What's the derivative of y squared? 2y. And see how we took the derivative of a y term? So now you tack on that dy dx. And then we've got plus 4x. Derivative of 2x squared is 4x. And then equals, what's the derivative of 5? 0. Derivative constant term is 0. Whoop. All right. So we took the derivative. Now what do we do? What did it say? Solve for dy dx. So I've got 2y times dy dx equals negative 4x. Divide everything by 2y. And so we get dy dx equals negative 2x over y. And there's your derivative. All right. Now, before we go on to the next examples, let me show you this. So we've got y squared plus 2x squared equals 5. Now, this is how I like to do it, how I like to do the implicit differentiation. So let's do it. 2y, all right? So we took the derivative of the y term. So now I've got to tack on a dy dx, right? All right. But what the way I like to write it is, instead of writing dy dx, I like to just put y prime. Isn't that another notation for dy dx? You can put dy dx, you can put y prime, f prime, okay? There's different notations to represent the derivative. And so I just typically put y prime instead of dy dx. It's the same thing, 2x. Whoop. 4x equals 0. And then, you solve for y prime, you get y prime equals negative 2x over y. All right. And the reason the reason I put it like this instead of this, I write the y prime instead of the dy dx, it doesn't look as cluttered up. Okay? It's like you don't have a lot of, I don't know, it just looks a little cleaner and maybe can be a little easier to see it and solve it. Okay? That's all. So in these examples, in the rest of these examples, instead of writing dy dx, I'll write y prime. Now look, if you want to write dy dx, that's fine. Nothing wrong with it. Okay? All right. Let's look at our next example. So we got 3y to the 4th plus xy squared plus 2x cubed minus 6 equals 0. So let's take the derivative. Take the derivative just like we always do. So what's the derivative of 3y to the 4th? That's 12y cubed. We took the derivative of what? Of a y term, so it's times y prime. All right? And then we've got plus. Now, look at this term right here. We've got x times y squared. That's the product rule. Okay? So we've got to do the product rule on that. So the product rule is the derivative of the first. So the derivative of x is 1 times the second. Okay? Derivative of the first function, derivative of x is 1 times the second function, y squared. Plus, now it's the derivative of the second function. So what's the derivative of y squared? It's 2y. I took the derivative of a y term times y prime. So that's the derivative of the second term times the first term. All right. So look, all of this is the derivative of this term right here, using the product rule. All right, so now let's take the derivative of the rest of the term. So the derivative of 2x cubed, that would be 6x squared, minus the derivative of 6, that's 0, equals, and then the derivative of 0 is 0. All right, so now we have to solve for y prime. So this next step is not necessary, but since you're just now learning how to do this, I would go ahead and do it. That's 12y cubed y prime plus y squared plus 2xy y prime plus 6x squared equals 0. So all I did is I got rid of, 1 times that is just y squared, and then I just put the x first. You don't have to do that. I just like to put the x's and then the y's and then the y prime. All right. So now let's solve for y prime. So anything that does not have a y prime has to go on one side, and everything that has a y prime goes on the other side. So I've got 12y cubed y prime plus 2xy y prime is equal to negative y squared minus 6x squared. So I just moved the y squared and the 6x squared to the right hand side. And now look at this. I have a common factor of y prime. I can factor that out. So I've got y prime times 12y cubed plus 2y is equal to negative y squared minus 6x squared. So y prime is equal to, so here I'm just going to divide both sides by this. So I get negative y squared minus 6x squared over 12y cubed. Let's see, what did I do? Okay, you see what I did? I forgot I didn't bring that x with it. 2x. 2x. And so plus 2xy. And this would be your answer. All right. Make sure I didn't miss anything else. But yeah, and that's another thing. Of course I didn't do that on purpose, forget the x, but I'm glad it happened. Be careful when you're writing the stuff down. It's easy to miss something in all this. Okay? All right. So was not intentional, but glad it happened. All right. So let's look at this. All right. So look at this first term here. I've got product rule. I've got 2x cubed times y. So the 2x cubed, that's my first function. The y is my second function. So the derivative, it's the derivative of the first. So that's 6x squared. That's the derivative of the first times the second. Plus the derivative of the second. So the derivative of y, that's y prime, times the first 2x cubed. So this is the derivative of that first term using the product rule. All right. Now, look at this one. That's chain rule, right? We've got something in parentheses raised to a power. So we've got plus, so the 3 comes down. Subtract 1 from the exponent. And then times the derivative of what's inside the parentheses. So we've got to take the times the derivative of y squared plus x. So that's 2y, y prime plus 1. All right. And then we have equals 4x cubed. All right, so from this problem, you can probably see some of these things can get pretty nasty solving them. So how are we going to go about solving this thing? Well, let's see what we can do. All right, so let's go 6x squared y plus 2x cubed y prime. All right. Now, what I'm going to do here, you see the 3 y squared plus x squared, I'm going to take this and distribute it to each one of those terms in there. So that's going to be 6y, y prime. Yeah, we'll write the y prime, and then the y squared plus x squared plus 3 times y squared plus x squared. All right, so this term right here, that's from multiplying it to that one. And then I multiplied it to the 1 and got this. And then this is equal to 4x cubed. All right. So let's see what we can do now. I think now let's just go ahead and everything that doesn't have a y prime, let's just move that to the other side. So I've got 2x cubed y prime plus 6y y prime times y squared plus x squared equals 4x cubed. Now I'm going to move this over, so that's minus 6x squared y. And then I'm going to move this term over, so that's minus 3 times y squared plus x squared. All right. And so now you can see I have a common factor of y prime that I can factor out. So that's going to be y prime times 2x cubed plus 6y times y squared plus x squared equals 4x cubed minus 6x squared y minus 3 times y squared plus x squared. All right, and so now we just divide both sides by this, and that's going to leave us with y prime is equal to 4x cubed minus 6x squared y minus 3 times y squared plus x squared over 2x cubed plus 6y times y squared plus x squared. And there's your derivative. So, you know, I'm telling you that the implicit differentiation, it's not really that difficult, I don't think, to get this, to get your first step right here to go through and take the derivative. Where the more difficult part comes in is actually just solving for y prime. That can be the toughest part of the problem. All right. All right, so now let's get to some applications. I think we got 3 more problems to do. So find the slope of a line tangent to the graph of this at the point -3, 1. All right, so do we know how to find the slope of the tangent line? Well, of course we do. If you've been watching these videos, we know to find the slope of the line that's tangent to the curve, we find the derivative and then evaluate the derivative at the point. Okay? So let's go ahead and do that. So I've got 2y cubed plus xy plus 1 equals 0. So let's take the derivative. So that's 6y squared times y prime plus, now here I've got the product rule. See this? This is the product rule. So it's the derivative of the first, which is 1, times the second, plus the derivative of the second, which is y prime, times the first. And then plus the derivative of 1. What's the derivative of 1? 0 equals, and then the derivative of 0 is 0. And so now let's see. This term doesn't have a y prime. All right, so this is where, remember how I told you we can rewrite it and kind of order everything up and clean it up a little bit and then solve? Well, let's not do that on this one. Let me show you what I was talking about. So see how this term doesn't have a y prime? So I'm going to go ahead and move it over. So that's going to be 6y squared y prime plus xy prime equals negative y. All right, and I'll say this, another thing you can do in this step, typically when I teach this section, I show everything kind of like I'm doing in this video, and then after that, if we come across some implicit function, in this step right here, I would have gone ahead and factored out that y prime also. You can do that too, but let's just go ahead and factor it out here. 6y squared plus x equals negative y. And so y prime is equal to negative y over 6y squared plus x. All right, so what's the slope of the line that's tangent to the curve at the point negative 3, 1? So we got the point negative 3, 1. So this is y prime. I'm going to evaluate it at negative 3, 1. I've got to put in the x and the y. And so that's going to be negative 1 over 6 times 1 squared plus negative 3. And that's going to be negative 1/3 is the slope. All right. All right, we got two more. Some word problems here. It says, oil moves through a pipeline such that the distance s it moves and the time t are related by s cubed minus t squared equals 7t. Find the velocity of the oil for s equals 4.01 meters and t equals 5.25 seconds. We've got an implicit function here. Now, how do we go about finding the derivative? Well, we're going to use implicit differentiation. What are they wanting us to find? The velocity. Okay, so think about this. S represents the distance. T represents time. Okay, so in this problem, if I want to find the velocity, well, haven't we looked at that in other videos? The derivative of the displacement function is velocity. So we're finding the derivative of s. Okay, so in this problem, s is like our y and t is like our x. So t is the independent variable, s is the dependent variable. All right, so what does that mean? Well, we take the derivative just like we always do, but when we take the derivative of the s term times s prime. Okay? All right, so let's write the function down. All right, so I've got 3s squared times s prime minus 2t equals 7. And now what do? Well, now we solve for s prime. So I've got 3s squared s prime equals 2t plus 7. And so s prime is 2t plus 7 over 3s squared. There's my derivative. And so now I'm going to take s prime and I'm going to evaluate it at 4.01, 5.25. I'm going to plug the 4.01 in for s and the 5.25 in for t. So that's going to be 2 times 5.25 plus 7 divided by 3 times 4.01 squared. And what do I get there? I have no idea. So I've got to punch this into my calculator. All right, and whoop. divided by 3 times 4.01 squared. And we get 0.36, and that's going to be meters per second. So assuming I did not hit a wrong button in my calculator, there you have it. That's the answer. I don't think I did. So all right, so there's the answer to that one. All right, so last problem. Let's look at this one. It says the polar moment of inertia I of a rectangular slab of concrete is given by I equals 1/12 b cubed h plus bh cubed, where b and h are the base and the height respectively of the slab. If I is constant, so I is a constant term, find the expression for dBdh. So we want to take the derivative of b with respect to h. So which ones are independent variable, which ones are dependent variable? So our dependent variable is b and our independent variable is h. So b is acting like it's like our y term, and h is like our x term. All right. So let's write this down. I equals, now let me tell you what I'm going to do. Yes, the 1/12 is out here, but I think what I'm going to do here is I'm going to distribute the 1/12. Okay. And so I've got 1/12 b cubed h. Well, you know something? No, let's not. Let's just leave it out there. I don't know which one's going to be easier. If we distribute the 1/12 or leave it, I don't know. I've never worked this problem. So, I mean, right here I've got to use product rule. Okay. Here and here I've got to use product rule. So let's just leave the 1/12 out there and let's just see what happens. So the derivative of I, that's 0. So how do I know that's 0? Because it tells us up here if I is constant. So I is a constant. That equals 1/12 times, okay, so let's leave the 1/12 out. And so let's take the derivative. So I'm going to take the derivative of this. This right here, I've got to do the product rule. So the derivative of b cubed is 3b squared times what? B prime. Remember, b is like our y term, times the second function. So this is the derivative of the first times the second, plus the derivative of the second. Derivative of h is 1 times b cubed, plus, okay, so this is the product rule of the first term. Now, let's look at this. Now we've got to take the derivative of this term. You see that? So I'm going to use the product rule. The derivative of b, that's b prime, the derivative of the first, times the second, plus the derivative of the second. Derivative of h cubed is 3h squared times the first. So this is the derivative of that second term. Okay. And let's go ahead and put that in, that's in parentheses. Okay. All right. So let's see what we can do. We've got 0 is equal to 1/12 times, now I'm just going to clean this up a little bit. That's going to be 3, let's do this, 3hb b squared, no, 3h b squared b prime plus b cubed plus h cubed b prime plus 3h squared b. All right. Now, one thing I could do is I could distribute the 1/12, but I could also do this. Just multiply everything by 12. So 0 equals 3h b squared b prime plus b cubed plus h cubed b prime plus 3h squared b. So I multiplied everything by 12. That knocks out the 12s there, and then 12 times 0 is 0. And so now the fraction's gone. So now let's and I guess I could have multiplied 12 up here and had 12i, and then that would have got rid of the 12 down there also. Okay, see, so sometimes when you work these things, you know, you start out one way and you say, oh, well, I could have done this and it made it a little bit easier. Yes, it even happens to me. It happens to me sometimes. All right, so let's solve for b prime. So this is going to give me negative b cubed minus 3h squared b equals, and now it's this plus this, but let's go ahead and factor out that b prime. So we're left with 3h b squared plus h cubed. And so now I get b prime is equal to, going to divide both sides by this, negative b cubed minus 3h squared b over 3h b squared plus h cubed. And that's what they were wanting us to find, the expression for the derivative of b. And I don't think I made a mistake. So that one was, it wasn't hard to work. It just, I don't know if you could tell, if you could even tell following along that, you know, you taking this derivative, it just gets kind of, it's weird when you have b and h in there, not x and y. So, but yeah, that's the answer. I don't think I made a careless mistake on it. I have no way to check my answer. This is actually an even number from the book, so there's no answer in the back. No, I don't have a teacher's edition to this one, to this book. But yeah, that's implicit differentiation. So I hope this helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I will see y'all in the next one. Later.